Hello everyone and welcome to the Cambridge IGCSE 0606 CIE Additional Mathematics course, and in this video we will be covering the seventh chapter, which is straight line graphs. So let's get started. Now the first thing you should probably know are the forms that straight line graphs come in. So you could have this first form, which is y is equal to mx plus c, where m is the gradient and c is the y-intercept. This is the simplest and the most common one. This is also called the slope-intercept form. Now, the second one isn't actually a technical form. It's sort of a formula which you substitute the values in to actually and then rearrange it to get the first form, but I'll discuss it. Basically, y minus y1 is equal to m multiplied by x minus x1. So m is again the gradient, and then x1 and y1 are actually is one point that lies on the line. So these are the coordinates to that point. Now the third form, this is actually the general form, is ax plus by plus c is equal to 0. So basically everything has just been sent to one side. So it's like this, except so it becomes y minus mx minus c is equal to 0 for this one. And if you actually were to then rearrange it, you would actually get y is equal to minus a by bx minus c by b. And so if you equate it to this one, you can see that the gradient is negative a over b and the y-intercept is negative c over b. All right, now let's move on to some formulae that you can sort of use if you are given 2 points on a line. So the gradient of that line can then be found with y2 minus y1 over x2 minus x1. The midpoint can be found by basically averaging the two coordinates, and the distance between these 2 points can be found by the distance formula, and you will need to remember these for your examination. Now moving on, let's talk about parallel and perpendicular lines. So if you have two lines that are parallel to each other like this, then their gradients are actually going to be equal to each other. And if you have two lines that are perpendicular to each other, then their gradients multiply to -1. They're also called as negative reciprocals of each other. So if you were given this gradient, let's say the gradient m1 is 3, then m2 will be -1 over 3. So just take the negative, and then take the reciprocal, which is just 1 by 3. All right. Now let's talk about the perpendicular bisector. So the perpendicular bisector to a line is basically just is a perpendicular line that actually intersects the original line at its midpoint. So as we found here, if you're given 2 points that lie on a line, so again, if I have the Cartesian curve, I have, let's say, point A over here and some point B here. So this will be some line that goes through A and B. Then let's say midpoint M approximately over here, and you have a line that passes through M. So this line L2, if this is L1, L2 is actually the perpendicular bisector to L1, and that's just stated here in words. Right. Now, so this is actually something new. So basically what this part of the syllabus is, you can convert a non-linear equation such as this one into a linear form. So if you see if you have looked at the last chapter, which talks about logarithm and exponents, you can see that if we take the natural log on both sides of this equation, it'll rearrange to this. I can show you the working for that here. Say y is equal to ax to the n. This gives us natural log of y is the natural log of ax to the n. Now, using the properties of logarithms, we know that we can actually separate this to the natural log of a plus the natural log of x to the n, and the other property for exponent states that this is just going to be this. So similar to this, and then if you actually equate it to the general form of a straight line, which is y is equal to mx plus c, you can see that because this is x, so ln y will be y, ln x will be x, n will be the gradient, and ln a will be c. And you can do the same thing for an exponential one of this form. Same process, equate them and do that. So this is actually a useful technique. If you're given a nonlinear equation, you can actually sort of approximate it and it becomes linear, which is actually linear equations are easier to deal with than some random curve that looks like this, right? It's a straight line, nice straight line that'll probably go like this. Now, this is basically the reverse process. So if you add an equation, y squared is equal to ax cubed plus b, you can equate it again. A will be m, b will be c, y squared is y, and x cubed will be x. So the same thing as this, but this is actually an example question. So let's say we are given this equation and we are to find the values of a and b. We are to find the actual nonlinear equation, what that would be. So let's say these are just some generic points, 1 comma 5 and 8 comma 9. That may not actually work, but basically if we are given these 2 points and we say that they lie on this line, y is equal to mx plus c, well then we can find m, which is the gradient, which is also equivalent to a, so we find that 4 by 7. Now using the second form that we discussed at the start of the video, you see that y minus 5 is m times x minus 1. Rearranged to solve, you actually get this, which is the equation. So now we know y is y squared, so y squared is equal to 4 by 7 x cubed plus 31 by 7. And let's just put into our calculator and check. So 4 by 7 into 1 cubed plus 31 by 7 gives us 5, which actually is technically correct, but it isn't y squared. So obviously I just made these numbers up. Your examination values will somewhat be correct, but this is basically the process. You'll be given you'll be either be told that this can be converted to linear, so you'll have to do that. You'll have to show that it actually can be, such as this one. Then you'll have to find the values for m and c, sort of judge them or basically look at the pattern, how they equate to each other, and solve the thing. But yeah, that's about it. Thanks for watching.